on track. So this week, our goal is we're doing 2 sections today. Actually, and we're going to finish up pretty much all of chapter 2. I've taken some of the stuff out that I feel is sort of older stuff that really isn't applicable, because what we're going to do is teach you how to use technology for a lot of things. So some of the stuff that hasn't been in a typical statistics course was invented before we had all this technology, because that was kind of the only way to do it. So we'll take those out. We're then going to get into chapter 3 on Tuesday and Wednesday. And so that will finish us up with the content that we're going to have for the next test. So then we actually do have the 3 chapters. So chapter 1, chapter 2, and chapter 3. And then we've got all next week. We've got some time to do review. And then I gave us sort of 2 days for the exam. We'll see. We probably only need 1, but we've got some room in there. So the goal is by the end of next week to have our first exam. Okay. And we've actually... Thursday is no class. Yeah. So, but I wanted each day blocked out there, because you have Thursday to maybe do some work if you can work it in, but it's a day we don't have instruction, right? And then Saturday, Sunday is also on here. So that's over the weekend, when you should be finishing up with the homework quiz, or the reading quizzes, the homework quizzes. And again, once we go through that practice quiz, you'll have the idea of everything that we need to do. So hopefully we can get those finished up. Any questions on what our goal for this week is? And okay. So then let's go ahead and get... Yes, yeah, chapter 2 notes. That's right. Good. Thank you. Okay, so just letting you know, in chapter 2, I've narrowed it down to 2 main sections, section 2.1, 2.2 in the notes. We will pick up a little bit from 2.3, but not all of it. And I'll let you know which ones. There's something called a stem and leaf plot, which I've taken out. There was just a few problems on it anyway, so we'll take those out, and those get replaced by something else. So if you go into the learning objectives, that's where the slide deck is. Also, copy of the notes if you need them. And this is where I will post this recording of the class session. All right. So now we're getting this chapter strictly descriptive statistics. Okay. And actually, chapter 3 will also be descriptive statistics. This one, we're going to focus on how to graph things so we can take a look at things. We get to chapter 3, we're going to do more calculations, finding the average and finding how measurements for how spread out the data is. So those are the 2 goals we have for this week. So the first type of organizing of data we do is called a frequency table. Frequency distribution. Now, that word distribution might throw you off, but it's just distributions, how things are distributed. So if we have a bunch of just raw data, a bunch of numbers, we're going to take a look at that. It's hard to tell what's going on. So we can do a table like this, and we're first going to start with a table that's been done, and then we'll work back to the data. So what a frequency distribution is you group the data. So whatever, this doesn't tell us what kind of data is, but we have classes. So that any data points between 1 and 5, this tells us is that there were 5 pieces of data that were 1, 2, 3, or 4, or 5. We don't know which one, but in that group there were 5 pieces of data. Does that make sense? And then in the number 6 to 10, there were 8 pieces of data. Again, it's a very generalized look. We don't know specifically what those datas were, but we know in that group that's how much. Okay, so it helps us get a more general look at things, and you'll see each of these. This is how many pieces of data are in this class, and that class is giving us a count. So between 16 and 20, there are 8 things. Okay. And again, we focus on vocabulary a little bit. We'll call them classes, or we can also call them intervals, right? From 1 to 5 is an interval. We also call it a class. Okay. And then also always associated with that is the frequency, how often that piece of data occurs. Okay, so then how we go about, we're going to actually construct these today from data. So each class has what's called a lower limit. And again, here, it kind of makes sense, right? 1 would be the lower limit. 5 is the upper limit for the first class. Okay, so we got a lower limit, upper limit for each class. And we're going to figure out how, what we're going to do is take a big chunk of data and figure out how to calculate those. Okay. And this is part of the calculation process. Once we have our classes, we can calculate the width by taking the lower boundary of one class, subtracting the lower boundary of the next class, and you can see 6 minus 1 gives us 5. You could also count it 1, 2, 3, 4, 5. It has a width of 5 data points. Okay, so that's what they're talking about, the width of the class. That's an important part. And then the other word we're going to bring in is the word range. The range is the smallest piece of data to the largest piece of data. Now, I don't know if there's actually a 30 in here, but we'll figure this out when we have it. I don't know how to turn the ringer off on this thing, but it's a new phone and nobody else has it. So anyway, okay, so we'll use the width and the range of the data to be able to, thank you. Okay. Thank you. So we'll have the range and the width. We'll need those things. Okay. So here, big chunk of data, right? Can you tell me anything about this stuff just by looking at all these numbers? Well, we know what it is. This is a list of cell phone screen times for 30 US adults. Okay, so it's how much time they're spending on their cell phones. Kind of good with that thing. So, and I guess there must be in minutes. Yeah, it tells us it's in minutes. But just looking at that data, it's kind of overwhelming, right? It's hard to tell. Okay, I can see 200, I can see 342, I can see the first and the last number, but there's a lot of numbers in between. So when we want to construct a frequency table, typically they will give us how many classes they want. So we'll use that. They tell us, in this case, they want 7 classes. So we got to fit all this data into 7 classes. So looking at that data, what do you think might be the best 2 numbers to pick out? Let's see, I think, oops, almost. This number looks like a very important number. Why does 155 look like it might be important? Good. So we want the lowest. What do you think the other important number is going to be? 400, because 405. So this is a hard part, is you think you got the biggest one and then, okay, is 405 the biggest? I think so. So again, it's just you got to go through the data, pick the lowest and the highest. Okay. First thing we're going to do is we're going to get the range. So we're going to take the highest and we're going to subtract the lowest. And that looks like that's going to give us, I'll do it this way. 5 minus 5 is 0. That's another 5. 1 from 3 is 2. 250. Get that much? And so we've got a range from the smallest to the largest of 250. And we want to fit those into 7 classes. We want to divide them into 7 classes. So what should we do mathematically? Divide. Yeah. When you want to divide things, you divide. So then we divide this by 7. And again, if they wanted 8 classes, we do it by 8. That I'm going to need to, I'm not going to try to do that mentally. So we'll go 250 divided by 7. I come up with 35.71. So what do you think I should use for my class width? Good call. Round it up to the next highest one so that we can fit everything in. Even if it was 35.2, we'd still want to go to the next highest, because if we went down to 35, we might not get it all. So go one higher. So we're going to use a width of 36. And where will we start? With the first piece of data, because that's the smallest, right? We start there, and then, so what's the first class going to be? 155, and the upper limit's going to be at 36 to it, right? There's the 1, that's 8, that's 9, 191. So you can see how we can start constructing our classes, right? Okay, so now there's the instructions. Typically, we choose between 5 to 20 classes. And again, the reason we do that is because if you do more than 20, it's like too much going on.
Imagine Bo Pinthong spiritual science.
Sorry about that. In fact, I think this one I can turn off. There we go. Okay, so 5 to 7. And if we had less than 5, like you only do 3 classes, a lot of times you just get big, what we're going to do, you don't get enough information. Okay, so that's kind of just a general rule. We already followed through. We took the largest minus the smallest to get our range. Then we divided it by the number of classes, and we rounded up to the next convenient number. So you guys had kind of that input that seems natural to do, right? So number of classes equals 7. Find the class width. So again, we rounded up to 36, so we went ahead and did that. Find the class limits, use the minimum data as a lower limit of the class, add the class width to the lower limit, find the next, and then subtract 1 from the lower limit of the second class to find the upper limit of the first class. Okay, so one thing I got off a little bit on is the class width gives you from the bottom, the minimum, to the minimum of the next one. So what this did is we should have a class that starts at 155. The next class, because a width of 36, it'll start at 191. So the first class has to go to what? 190. Okay. We add 36 to this one, and we will get 7. 3 plus 9 is 12. Carry the 1, 227. And then what you do is the top end of this one's 227 minus 1, 226. Okay, so you could sort of start making your classes that way. So yeah, they just add the 36 to get to the lower limit of the next one, subtract 1, and we've got our 190. You'll see you could get all the classes. So it's just kind of a little tedious, and I think in the homework you'll have one where you're given a block of data and basically asked to do the same thing. Just make this little chart. So we've got our classes. What's the other thing we need for a frequency distribution? Classes is one part, and what's the other part? Frequency. Now this is the tedious part. How do we get the frequencies? Okay, so we've got the classes, and you can see subtract 1 to get to that one, and then you just put them all together. To get the frequencies, you take the data, and then we know that the first class is 155 to 190. And again, your data may be different. So we have to go through here, and we have to find all the, okay, there's one piece. So that's, I put a tally. 165 is between 155 and 190. I put that tally. And according to that list, there should be one more. Look through all the, oh, there's a 168. You just have to go through and see, okay, that's all there is. So there were 3 pieces of data. You had 3 tallies, and then you could put that it's a frequency of 3. You go to the next class and you look for all the numbers that are between the lower and the upper. Count them. Frequency, that's all that's going on. So it's a count. It's tedious though, and it's easy to miss one or maybe double counts one. So especially as you get higher and higher, like between 299 and 334. Notice there's 5, 6, 7 of them. So again, it's easy to maybe miss one. Also, if it's on the computer, you might not have the ability to cross things off, but that's what you've got to kind of do is when you're creating this. The good news is we're going to look at ways of where we'll enter it into like a calculator, and the calculator will produce all of this for us. Okay. Another important point once we have a frequency table, because we're going to use this for the graphs, is the midpoint of a class. How do you think we're going to get the midpoint of a class? Lower plus the upper divided by 2, right? Because if you add 2 things together, divide by 2, you'll get halfway between them. So on this one, 155 plus 190, we divide it by 2. That gives us the number that's halfway between those two. Okay, and again, we can just 155 plus 190 equals, that's 345, divide that by 2, and we get 172.5. Okay, because in thinking of this frequency table, a lot of times we don't know it's numbers in between those two, right? We don't know if they're all at the beginning, all at the end. So what we will do is sort of the average is about 172.5. So you're going to see there's one way of graphing it where we take those midpoints. We would do that for each of these classes. Okay. And finally, another thing we add, so we've got the frequency. We saw that it was a number. So 3, 4, 5, 6, 7. The other thing we would like to know is the relative frequency, which is a percentage, because then we can compare those maybe with some other data of a different size. Say 20% of the data is in this class, right? And the way we do that is you take that frequency and you divide by the total sample size. So let's just kind of go back to this. Notice all the frequencies, if you add them all together, you get that there were 30 pieces of data in that sample. Actually, at the beginning, it told us that this was the data of 30 adults. So we knew that there was going to be 30, so it kind of gives us something to match. So to get the frequency of the first class, we take 3 divided by 30, and that's about 10%, 0.1. Yeah, 0.1, 1, which is about 10%. Okay, and so the frequencies we can list, or the relative frequencies, we can either list as decimals or as percentages. And with the relative frequencies, what does the relative frequencies always add up to? 1 or 100%. So a decimals will add up to 1. If it's percentages, it'll add up to 100%. And I think we have just basically completed. Oh, one more thing. Sometimes we'd like to, especially like if things are put in an order, grade or ranked, we'd like to know the cumulative total. So we start adding it. So what we would do for the cumulative amounts is the first one would be 3. The next one would be 2 plus 3 is 5. So I could quickly go and say how many are less than 226? 5, okay, because that's the cumulative amount. The next one, 5 plus 5 is 10. So again, it gives you a quick way of saying how many are less than the upper limit to 262. You've got this cumulative count. So that's another part that is typically in a frequency table. Okay, so for each of the classes, you'll want to calculate the midpoint, and we're going to use that in just a moment on a graph. We'll calculate the relative frequencies. We'll use that in a type of graph as well. And then we also want the cumulative frequencies, which we're going to skip over that as far as a graph part, but sometimes it's important just to have that as part of the chart. Okay, so that's how they created this complete chart. Have your classes, your frequencies, that's what we started with. We calculated the midpoint of each class. We've gotten the relative frequency, and remember that's just a division, it's a percentage. And then we've also got the cumulative frequencies so that, when we get to the end, we can see, okay, it all adds up to 30, but we can also see what percent is below a certain score. We do that a lot in statistics. Any questions so far? The calculations are adding, subtracting, dividing, but just knowing how to kind of put it all together. Okay. So then once we have that frequency chart, we can then start doing some graphs. And one of the types of graphs we're going to use is a histogram, frequency histogram. Histogram is a bar chart, so the height of the bar tells us what the frequency is, or the relative frequency. The bars are touching each other because each class has to connect, and the vertical scale is our frequency, and the horizontal is our data values. So in our last case, that would be minutes using their cell phone. Okay. We talked about class limits, but when we do a histogram, since they need to touch, notice on our class limits, one ended at 190, the next one started at 191. There's space between them, right? They're not touching. So we need them to touch, and that's not too hard to do. So we call those class boundaries, okay? And simply what we do is we take these class limits, 155 to 190, and we add and subtract 0.5, a half, so that now they're going to touch. So notice 190 to 191, that's a whole 1. So if we do 190.5, 190.5, they're touching, but we won't have a piece of data that is like right on the boundary now. This is a way we can, because when we set up our class limits, we're thinking of the data. But then we've got spaces between them. So to do it for the graph, we put these in. So you'll see class boundaries are typically going to be halfway between these, okay? And then what that's going to allow us to do, 0.5, so subtract and add that half of 0.5, and you get your class boundary. And then when you do your chart, you can now do it in two ways. So one way is to label it with the midpoints. So notice here, they've just taken the midpoint of 172.5. These are each of the midpoints. And then you've got your frequency here, and that gives you the height of the bar. The other way to do it, depending upon how they ask for it, is with class boundaries. And notice this has the 154.5 to 190.5. And again, nothing's going to be on the boundaries themselves. They'll be in between. And again, the same bar has a frequency of 3. So I can represent it either by the midpoint or by the class boundaries. Okay. And depending upon which software you're using, sometimes that's an option to have it show up. And again, a lot of the nice part of the software we use is that we'll just take that data for you, put it in it. You have to tell it the class width you want or the number of classes, and software will automate a lot of this. We want you though to understand what that software is doing. It's not just magic. It's just doing some simple mathematics, but it's tedious if you're going to be doing these kind of things and producing these types of charts. There's a number of different software programs that will do these for you. You just have to give it the data. Okay. And so here's an example, and you can kind of, from looking at this, okay, they came up that you can determine that 2/3 of the adults are spending more than 262 minutes. Okay, here's 262.5. So you could add these up or visually see, I don't know. I would add them up. I'd get 7 and 7 is 14. There's 20 of them there. So 20 out of 30 are spending more than 262. So a lot easier than if you saw that data, it would take you a while to figure that out, right? But now that we've got it organized in this chart, it's easier to sort of start seeing these and answering questions about that data. Does that make sense? Okay, so this is the descriptive part where we're just organizing data into charts. Another thing we can do with this exact same data, this exact same chart, is something called a frequency polygon. A polygon comes from geometry of vertices connected with lines. And what we're going to do is each of these dots, these points, is going to be the midpoint, from the midpoint of the class and the frequency. Okay, so they're just going to plot these points and then connect them with a line. So in our case, we will use, on the x-axis, we will use the midpoint, 172.5, and we could use either the relative or the frequency. And again, a lot of times they'll use the frequency, but sometimes if they're wanting it to compare to like a population, we use percentages because that can apply to any size group. So notice here are all the midpoints, and 172.5 had a frequency of 3, so they plot a point, and then they just connect each of those points with a line. And again, there's software that will do this as well, but we want you to understand. See, once you've got that frequency table, we can do multiple things with it. Okay, so this is another way. How is this representation different than the bar chart? What can you see differently in here that maybe you wouldn't see in a bar chart? Maybe patterns over what's, it goes up, it goes down. Good, I saw it, I picked that up. So yeah, this is just a different view. It sort of focuses on trends. The bar chart kind of focuses how many are spending at each, so it's, they're both helpful. Okay. We will show technology later, but in the homework, you're going to have just a few problems where you'll be doing it by hand, and then we'll come back and review. And then this is going to be the easier part. Now that we've got it all together, we have a table that says relative frequency. We have one that says frequency, right? How would we do a relative frequency one? Well, we do the same thing, except instead of using 3 for the height, we'll use 0.1. and we'll use 1 as sort of the highest point because nothing could be more than 1, right? And so we see the scale over here, actually the highest, nothing's more than 25%. So we can go up to here. So our scale is now a percentage rather than a quantity, a number of a frequency, okay? So, and the cool part about this, I think this is almost the last slide here, is that you can see those things, but look at the shape of the one with the frequencies, the numerical frequencies versus the percentages. Look pretty much the same, right? Maybe the widths are a little bit different because they drew them differently, but they're going to give you pretty much the same results. So, but again, 1 gets you to focus on percentages and is easier sort of to apply to a population now or to a different sample. When I use exact amounts over here, I'm really stuck with only being able to apply it to this sample. So we'll start to see where we can, if we want to go from a sample to a population, right? Descriptive to inferential, we would want to use the relative frequencies. So far, so good? Okay. And then what we're not going to do is, this is from that other class, but we're not going to do, there's OGIV graphs, which is built off of the cumulative. We're not going to do stem and leaf or dot plots. Okay. But what we will do are a couple more types of graphs that will be beneficial for qualitative data. So we're going, how far do we go? We go to 9:55? Okay, so we'll be just about good, and then we can start working on these tomorrow. So a pie chart. How many of you have heard of pie charts? See them all over the place, right? It's a circle chart, and what do each one of those slices represent? How much? A percentage, good. Yeah, and so we'll typically, that's a relative frequency, so it can be taken from a frequency chart. And we might just have some data like this: associate's degree, bachelor's degree, master's degree, number of people who have earned those in thousands. So these are large numbers, right? Because you would put 3 more zeros on the end. So this is actually 1,037,000. But a lot of times we'll look at data in units of thousands, in large numbers. So what are we going to want to do? We want to get the relative, we want to get the percentage. So to do that, we'd have to take, for associate's degree, we take the 1,037 thousands, and what would we divide it by? Total. So we have to get that total. Okay. Sometimes they give it to us. I don't think they gave it to us though, did they? They didn't. Okay. Actually, I think they give it to us on the next, so we can maybe, well, they didn't. So we take 1,037 plus 2,013 plus 834 plus 188. So I've got that there are 4,072. And remember, that's in thousands, so that's actually 4 million people. But when we divide that, we get the 25%, actually 4.6, which they rounded to 5. So they get this number. And they would do that for each of these. How do we get the angle? We've got the percentage, because a circle, how many degrees are in a circle? 360. So then what we have to do is you take this percentage, this is where percentages are helped, or this decimal, which is a percentage, you multiply it by 360 degrees. So if you take 0.22 or 0.255 times 360, you'll get the 91.8 degrees. And then you could use your protractor and figure, oh, it's about 90 degrees and um, a little bit bigger than 90. And then you could just kind of hand draw it. Again, we've got software that will actually do all of this for you, so you won't do it. But what we want to do is, so it's not a mystery or it's not just magic. I plug numbers in and I get my answer. You know what is going on. That software is doing that in the background. Okay, does that make sense so far? So pie charts, you do that for each of them, and then you could divide your circle up, and you've got a nice visual. So which one of the degrees can you tell by looking at that has the most people getting it? Bachelors. It's like half of the pie, right? Um, and you might have spotted it from here, but again, unless they give you the total, um, it's hard to see. But it's a nice, quick, easy way to present. You want to make a point that we should put more money in our bachelor's degrees because that's what most people are doing, right? Something like that. Okay. A similar type thing that we're going to use is a Pareto chart. I'm not sure if I'm exactly pronouncing that right, but it's a bar graph. These do not touch each other because these are from qualitative data, right? Categories. So they're going to represent categories, and they're going to be the bar chart that represents the height, will represent sort of the frequency of each category. But the other thing we do with these charts is we put the bars in order from tallest, the most to the least. So notice the tallest bar positioned at the left. So they'll always go kind of downhill on you. So for that data, well, here's some other data we had. Leading causes of death in the United States, accidents, cancer, all of these different causes. The one that is the highest is cancer. No, heart disease, actually. So we put heart disease first, and we draw a graph, a bar that goes up to about 659, and we can just show that picture as we go. So that's a Pareto chart. Okay, just put the categories in order from most to least, and then it's just a bar chart. We don't have to make classes or anything as we did with the frequency tables. So again, a way to do almost there. What I'm going to no, we still got enough. Let's go ahead and we'll do this. So then tomorrow we'll start in with a little bit of the homework, and then we'll pick up the last part. So a scatter plot. For a scatter plot, we need two pieces of data for each data point. Okay, so this is showing a relationship between something. So let's take a look at what that might be. A statistician, Ronald Fisher, he wanted to see if there's a relationship between the length of a petal. This is in the iris data set. So these petals or leaves, petal lengths. Yeah. So he took the petal length and the petal width. So you want to see if the longer petals had wider or if there was any kind of relationship. So there's two measurements for each petal, right? The length and the width. And so to create a scatter plot, what they need to do is they want to see, does the petal length increase as the petal width increases? And so they would put the petal length on the x-axis, the petal width on the y-axis, and what do you see is as the length increases, what's happening to the width of the petals? They start, if I sort of drew this line, it's going up. So as they get longer, they're also getting wider in general. Now some are a little different. This is what's called a scatter plot, and actually we'll do this a little bit later. That line I just drew is called a regression line, and there's some complicated math. Again, we'll use a technology to do it, but you can also visually kind of say, well, that's looked like a pretty good fitting line, right? kind of averaging out the points. So this is the beginning part, though. We're just looking at the scatter plot itself, but we're going to come back to this and do some really cool advanced stuff with it. Okay, but you can see you need two pieces, each leaf has two pieces of measurement, right? It has its length and its width. And so you'll see with a scatter plot, every sort of item you're interested from that sample will have two measurements. Like a house, you might, you're selling a house, it might be the price that the house sold for and how many square feet are in that house. It's always going to be two measurements for every piece of data. And then it plots an X and a Y. And so this brings you back maybe to some things you did in algebra, right? X and Y coordinate system. Okay, last one we're going to look at, I think it's the last one, is what's called a time series. And this, one of the pieces of data, it's things that are changing over time. And so one piece of your data is time and the other is a measurement. So maybe this is a plant as it grows, right? And so, or in this case, burglaries over time, how many millions of burglaries there are over the years. And again, what we do is this is kind of like a scatter plot, but it's each, on the x-axis is the time, right? Here's the year on the x-axis. The y-axis is simply a dot from the data, so no advanced analysis done, and then we just connect it with a line to see a trend. And what would you say about burglaries over time with this chart? They're going lower, right? So that's maybe good. We do the same thing with robberies, but notice robberies are in thousands, so it would be a very different scale. So sometimes you can plot more than one time scale on there. Okay, so again, just a quick look at the data. So, because sometimes the numbers themselves, you don't see much, but if you see a visual, you can clearly see it's going down. Okay. Keep clicking and no more. So that's the end of today's. So when you go into the homework, what you're going to see is all these different types of charts. There'll be a problem about how to construct one, or they may give you a chart and you have to pull some information off of it. So what we'll do is we'll start in, perfect timing. Tomorrow we'll get a little bit of time to start into it, and then we'll go into our last part of actually doing some calculations for the middle and the spread of data. Okay. So if you get time later on today, a good thing might be is to look at your notes and go back through the readings and try to hook those up, and any vocabulary, fill in the blanks. All right.